3 project themes related to Design for Life were taken up, applying currently developing technologies at Keio University. We proposed BIMUS, a biologically inspired medical operation system. Many medical operation systems today are almost totally dependent on the needs of the surgeon and existing technologies. We propose a novel system focusing on the interaction of a surgical system and hierarchy of technical systems. Interaction is a major feature of biological systems, and integrating interaction and hierarchy is critical in formalizing a novel medical operation system. This is the flow of the whole system. The main features are concerted medical service through informed consent and simulation-based laparoscopic surgery. As for the informed consent, at present, the patient is not fed enough comprehensible information, thus unable to actively participate in choosing the treatment. Our system explores ways for concerted medical service, in which the patient can make their own decisions with the support of doctors. The patient will be provided with easy-to-follow information through 3-dimensional modeling, use of database, and large LCD screens. Simulation-based laparoscopic surgery. Laparoscopic surgery requires extremely high technical skills, and lack of experience can lead to fatal accidents. BIMUS allows the doctor to train and practice through simulation, using information obtained from past surgeries and 3D modeling of the human body. With enough time to prepare for a surgery, reliability of the whole system will greatly improve. The hierarchical design modeling method. A technology still under development at Keio University was implemented in designing the proposed surgical robot. Other technologies such as the master-slave combined manipulator and effectors using multi-DOF ultrasonic motors are also some of the new technologies introduced. Simulation and surgery will be conducted, taking advantage of these developing technologies, and will lead to producing new values. This group proposed a novel surgical system, BIMUS, a biologically inspired medical operation system, integrating the interaction of surgical systems and the hierarchy of technical systems. We propose a traveling vehicle, life support vehicle, for the elderly and challenged people. We set out to make their lives more active and satisfactory. We designed a vehicle car that supports the journey, and a vehicle chair that supports activity at the destination. In designing the vehicle, we were inspired by creatures that bring up their infants in their mouths. The vehicle is composed of 3 systems. The 3 systems include a riding system, comfort system, and driving system. With 3 systems, we developed a life support vehicle for 2, through collaboration between the vehicle car and vehicle chair. These are the exterior and interior design of the proposed vehicle car. In designing the vehicle car, we use the shape design method using macroscopic shape information. That is a digital design method under development at Keio University. This method helps create ideas of shapes easily. Using this method, we propose a way of styling a life support vehicle. Next, this is the design of the vehicle chair. In the vehicle car system, the person rides on a wheelchair and can drive the car remaining seated on the wheelchair. The difficulty of getting on and off the car is eased by making the front and the rear open. The driver may get on the vehicle from the rear and get off from the front. To handle a vehicle car in the same way as handling a wheelchair, we applied a by-wire system. When handling a wheelchair, vibration greatly affects comfort. Therefore, our system makes use of an active vibration control system, which is also currently being developed at Keio University. In addition, we propose the structure of rotating seats for the vehicle car, which is suitable for the concept of life support vehicle for two. We also propose a broken structure, a seat swing structure, and a pressure distribution structure to reduce fatigue and to make time more relaxing for the two people on long-distance journeys. Future issues would be the verification of effectiveness when using a combination of these technologies. This picture shows the vehicle car and vehicle chair in use under the concept of life support vehicle for two. As you can see from the picture, using this vehicle car, you can travel to places where you could never visit in daily life, and you can share time with your partner on the vehicle chair at your destination. Our project is on artificial joint system interacting with organisms. We would like to propose an innovative artificial joint system under the concept of interaction between implant and organisms, viewing artificial objects and organisms from multi-aspects and an integrated point of view. In designing conventional artificial joint systems, the factor of organisms has been considered constraints, and we need to evaluate whether the implanted materials satisfy the constraints. However, in our system, the material interacts with the organism and external devices, and the constraints such as the surrounding environment can be eased. To realize our concept, we needed to add the organism as a component in the solution space, and to map from the meaning space to the solution space. As a result, the organism becomes one of the variables in designing the system. The hip joint is the subject of the system. First, we organized hierarchical meaning components necessary for an artificial hip joint using QFD and ISM. In addition, we found the technologies from a macro, meso, and micro scale point of view and introduced them into the proposed system. From a macroscopic aspect, we propose supporting tights for recovering athletic ability and reducing motion restrictions of patients after operation. This actuator-embedded supporter works synchronously with the motion of the human body, and we expect that it can be worn for some time after the operation. From a meso aspect, we propose a fluid injection system to improve tribology characteristics of the sliding part that substitutes lubricated body fluid of conventional devices, reducing wear of the joint. We also propose an optimized stem form using emergent form generation system. Emergent form generation system consists of a generation process and an optimization process. In the generation process, induction and apical dominance, two properties of organisms, are imitated to generate diverse forms in a self-organizing manner. Here is the process of form generation. In the optimization process, forms are optimized, while maintaining the diversity and features of the forms obtained in the generation process. The results show that the system can obtain diverse topological structures. These figures show examples of design ideas. The results show that unprecedented stem forms were obtained by the proposed system. From a microscopic aspect, the stem surface is subjected to fine particle bombardment, FPB treatment. FPB treatment is a newly developed surface modification process in which fine particles are bombarded to the surface with very high velocity, creating microtexture on the treated surface. In conclusion, we proposed an artificial joint system that improves the quality of life of patients with fine biocompatibility and reliability by realizing a new meaning of interaction between implant and organisms.